Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 3 video on the chapter of direct and inverse proportion, where I will solve the problems of exercise 12a from the textbook of author RS Aggarwal, which is based on direct variation. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video in solving exercise 12a from the textbook of author RS Aggarwal on the chapter of direct and inverse proportion. Okay, so as usual, I have the problems of exercise 12a on the left hand side, and on the right hand side I will solve the problems. After solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. And also a very important thing, that after solving a set of problems, you should always revise all the key concepts and formulas that you have used in solving the problems. If you do this for while solving, if you do this every time you solve a set of problems, or if you are solving problems from an exercise, or if you are solving any homework sheet, or if you are giving a test, always list down all the key concepts and formulas that was applied or used in solving the problems. This will give you a regular revise on the chapters, and this eventually will help all the concepts and the formulas to remain in your memory for a longer period of time. Okay, so let's now start solving the problems. The question number 1, there is a it has 3 parts. So observe the tables given below, and in each one find whether x and y are proportional. That is, it is asking whether the x and y are in direct proportion or not. Okay. So for the first one, so how do we verify whether the quantities, whether the values, whether the corresponding values of the quantity x and y are as per our correct data, so that the quantity x and y are in direct proportion? So we must have the ratio of all of them equal to the same constant. So x by y should be a constant, which is known as the constant of proportion or variation. X by y, the ratio of the quantity x by y, x and y, that is x by y, should be a constant, and which is known as the constant of proportion. So for all the corresponding values of x and y, their ratio must be the same constant. So let's see, for 3 by 9, for 3 and 9, the values, corresponding values of 3 and 9, the ratio is 3 by 9, which is equal to 1 by 3. So definitely the constant k must be equal to 1 by 3. Now let's see what is 5 by 15. 5 by 15 is also 1 by 3. 8 by 24 is also 1 by 3. 11 by 33 is also equal to 1 by 3, and finally 26 by 78 is also equal to 1 by 3. So we can see that the ratio of all the corresponding values is same, which is 1 by 3, which is 1 by 3. So for this data, for this quantity x and y, the constant of proportionality, the constant of proportion or constant of variation is 1 by 3. So this is in the quantity x and y are in direct proportion, or we can say that x varies directly with y. Okay, let's see the table number 2. We must have similarly we must have x by y should be a constant. Let's see what is 2.5 for the first corresponding value. The ratio is 2.5 divided by 10, which is equal to 25 divided by 100, which is equal to 1 by 4. Okay, let's see what is the ratio for the second corresponding values. 4 by 16 is also equal to 1 by 4. Let's see 7.5 divided by 30. This is equal to 75 divided by 300, and of course this is also equal to 1 by 4, and 10 by 40 of course is equal to 1 by 4, and the last corresponding values is 14 by 42. Now this is not this is equal to 1 by 3, which is not equal to 1 by 4. So therefore this for this the second table, the quantity x and y, the quantity x and y are not are not in direct not x does not vary directly with y, and to mathematically express that, I am using the symbol this. I am using this symbol to mean that, so this means mathematically when we write this, this means x and y are in direct variation, that is x varies directly with y. Now when if this is my convention, this may not be a standard convention. When I am using this symbol, I am striking away the vary symbol, then I mean that x does not vary directly with y, or x and y are not in direct variation. So for the table 2, x and y, the quantity x and y are not in direct variation, because for the last corresponding values the ratio is coming out to be 1 by 3, and for all other corresponding values the ratio is coming out to be 1 by 4. Okay, so for the table, let's see, for the table 3, as usual we must have x by y some constant. Now so for the first corresponding value the ratio is 5 by 15, which is 1 by 3. For the second corresponding values we have 7 by 21, which is also 1 by 3. For the third corresponding values we have 9 by 27, which is also 1 by 3. The next corresponding values, the ratio of the ratio of the next corresponding values 15 and 60 is 15 by 60. This is equal to 1 by 4, which is not equal to 1 by 3. Hence we see that there are the corresponding values, the ratio of the corresponding values are different for different corresponding values. So this means that for this table the quantity x and y, they are not in direct variation. Okay, okay, let's do problem number 2. It is if x and y are directly proportional, find the values of x1, x2 and y1 in the table below. So we have, so since it is already given that the x and y, the quantity x and y are in direct variation, we must have x by y, the ratio x by y must be a constant, which is the constant of proportion. Now from the table, from the corresponding values in the given in the table, we can say that 3 by 72 is equal to x1 by 120 is equal to x2 by 192 is equal to 10 by y1, and all these ratios must be equal to k. We don't know k yet, but should be equal to k. Now definitely k is equal to 3 by 72. Okay, now using this equality of the ratio of the first and the second ratio of the first and second corresponding values, we can find the value of x1. So we have, using these two ratio, we can say that 3, using cross multiplication, 3 multiplied by 120 is equal to 72 x1. So this implies x1 is equal to 3 multiplied by 120 divided by 72. So 3 divides 72 with 24, and 24 divides 120 with 5. So this is equal to 5. So x1 is equal to 5. x1 is equal to 5. Okay, now one thing I would like to say, that I am prone to make calculation mistakes. So if it happens in the solving any problem, please ignore that. Please focus in the concept I am applying and how I am understanding the problem and applying the concept of direct variation to solve the problem. That is more important. Okay, so we have this. Now again by again we can now you can consider the ratio of any two corresponding values to find to solve the unknowns. To solve x1, I consider the ratio of the first and the second corresponding values. Now to solve x2, I can consider the ratio of the first and the third corresponding values, or even I can consider the ratio of the second and the third corresponding values. That is, this is the second corresponding value, this is the third corresponding values. Okay, so let's see if because I know what is x1 is 5. So I know that x1 by 120 should be equal to x2 by 192. So this implies x2 by using cross multiplication should be equal to 192 multiplied by x1 divided by 120. And we know what is x1. x1 is already found to be 5. So this is 192 multiplied by 5 divided by 120. Now 5 divides 120 with 24, and 24 divides 192 with 8. So 8 x2 is equal to 8. x2 is equal to 8. Now to calculate, to find y1, I can consider the ratio of the first corresponding value and the last corresponding value. So I have 3 by 72 is equal to 10 by y1. So using cross multiplication, I get 3 y1 is equal to 72 multiplied by 10, and this implies y1 is equal to 72 multiplied by 10 divided by 3. This is equal to, y1 is equal to 72 divided by 3 is 24. So this is 240. So finally the unknown values are x1 is equal to 5, x2 is equal to 8, and y1 is equal to 240. These are the values of the unknown. Okay, let's solve question number 3. Now from the rest of the problems are all word problems, that is application of direct variation in real life problems. Okay, a truck covers a distance of 510 km in 34 liters of diesel. How much distance would it cover in 20 liters of diesel? Now in solving problems of direct or inverse proportion, the main task is to identify the quantity. Which are the quantities involved that you must consider to apply the concept of direct or inverse proportion. First, you have to identify the quantity, and if the quantities have some units, then of course all the corresponding values of one quantity must be in the same unit as the quantity So for x and y, so if x and y are in direct proportion, then if x and y have some different units, then all the corresponding values of x must have the same unit as y as x, and all the corresponding units of y must be of the same unit. Okay, now then the next task, then the next important task is to identify uh, the way how the two quantities are varying with each other. Are they in direct variation or inverse variation? So that is super important. So once you have done this, then you should be able to apply the concept of direct variation and inverse variation to solve the problem. You can also create tables. If you can create tables, it will be creating tables to solve the problems is a nice way of solving the problems. So in this, so let's identify the quantity. A truck covers a distance of 510 kilometer in 34 liters of diesel. Okay. It is asking how much distance would it cover in 20 liters of diesel. So clearly the quantities are, let's say, I am considering the quantity x to be the distance covered, distance covered in kilometer, and let's say the quantity y to be uh, amount of diesel consumed in covering the distance. So amount of diesel consumed, of course, in liters. So now clearly we can see that uh, if the distance covered is more, definitely more amount of diesel will be consumed. So x and y is definitely the quantities x and y are in direct variation. Now this is true because the mileage of the truck, the mileage of the vehicle is constant. Now what is mileage? Mileage is distance covered in 1 liter of petrol. Distance covered in kilometer in 1 liter of petrol. So if the mileage, you must be aware of the mileage of a vehicle. So if the mileage is 40 kilometer per liter, it means that in 1 liter it will travel 40 kilometer. So that mileage is this concept that the more distance you travel, the more diesel will be consumed is based on the fact that the mileage is constant. Okay, so we can clearly see that x will vary directly with y. So now if you create a table of data for the two quantities x and y, so it is given that a truck covers a distance of 510 kilometer. So I can say one corresponding value of x is 510 and the corresponding value of y is 34. Okay. The next, it is asking how much distance would it cover in 20 liters of diesel. So let's say, so let in 20 liters of diesel, x kilometer, not x kilometer, let's say x1 kilometer is traveled. We are assuming that in 20 liters of diesel, the truck is traveling x1 kilometer. So then we can add the data x1 and 20 in the table. Now we know that if we have a table like this of two quantities x and y, and the quantities x and y are in direct variation, we can say that the ratio of the corresponding values will be equal. That is 510 divided by 34 should be equal to x1 by 20. So from here we can easily solve for x1 using cross multiplication, and we have 510 multiplied by 20 divided by 34. Okay, so 2 divides 20 with 10, 2 divides 34 with 17, and 17 divides 510 with 30. So this is equal to 300. Okay, so x1 is 300 kilometer. So the truck will travel 300 kilometer in 20 liters of diesel. Okay, let's do problem number 4. Uh, a taxi charges a fare of 2550 for a journey of 150 kilometer. Okay, how much would it charge for a journey of 124 kilometer? So obviously, if the distance of the journey is more, the fare, the charge by the taxi will be more. So this is based on the concept that the rate of charge, the rate of the taxi charge, which is the amount of money per kilometer, that is constant. So we can, for this problem, we can consider the two quantities is x. Let's say x is a distance of journey. Now, in the previous problem, I assumed x to be the distance covered and y to be the amount of diesel consumed. You could have assumed the other way around, that you could have also considered x as the amount of diesel consumed and y as the distance covered. It would not it will give the same solution. So that is not a problem. You can always consider, the more important thing is that you should identify the quantity, which are the two quantities involved in solving the problem. Then you can consider x to be the one such quantity and y to be the other quantity, and then you create the table of x and y, and you make you make the ratio of x and y to be same for all the corresponding values, and then you solve the unknown. Okay, now for this problem, let's say x is the distance of journey, that is distance. So the taxi is going from some place to another, and the distance the taxi is traveling for a particular trip. Let's say this distance is in kilometer, and let's say I consider y to be the quantity taxi charge. Taxi charges. So definitely we can see that the more the distance is the journey, the more the distance of the journey is, the more will be the taxi charges. So definitely from common sense, we can say that x and y will definitely vary directly. That is, they are in direct variation. Now we can quickly create a table based on the given data. So it is given that a taxi charges a fare of, now taxi charges, let's say, is in rupees. So a taxi charges a fare of rupees 2550 for a journey of 150 kilometer. So one corresponding values will be 150 for x and 2550 for y. Now it is asking how much would it charge for a journey of 124 kilometer. So let's say, let charge for 124 kilometer be y1, not x1, y1, because charge is the quantity that is represented by the quantity y. So let charge for 124 kilometer be y1, be rupees y1. So then now we can add the corresponding values, 124 and y1 in the table. Now, applying the concept of quantities in direct variation, we know that the ratio of all the corresponding values, the ratio of x and y for all the corresponding values will be equal. So we can say that 150 divided by 2550 is equal to 124 divided by y1. Now we can solve for y1 using cross multiplication, and we get y1 is equal to 2550 multiplied by 124 divided by 150. So if we solve this, 3 and 551, and 3 divides 51 with 17. So this is 17 multiplied by 124. So 124 multiplied by 17, which is 28, 16, 8, 1, 24, 8, 10, 11, 2. So this is equals to 2108 rupees 2108. So the fare, the taxi charge will be rupees 2108 for traveling a journey of 124 kilometer. Okay, let's solve question number 5. A loaded truck covers 16 kilometers in 25 minutes. At the same speed, how far can it travel in 5 hours? Okay, so now this is a case of a speed and time and the distance. So when a vehicle travels at the same speed, then the distance covered and the time taken, they are in direct variation. So we can consider the quantities x to be distance covered, distance covered by truck, and that should be in kilometer, and let's say y to be, now here one thing is important, the unit will be play an important role. Now so one data is given that the truck is covering 16 kilometer in 25 minutes. So if we consider y to be the time taken, it is always recommended that it's a convention that so the speed of a truck, the speed of a vehicle is always the unit of speed of a vehicle is always kilometer per hour. So whenever it is so when the speed is constant, now this concept that the distance at a uniform speed, that when the truck is traveling, is moving at a constant speed or uniform speed, then only the distance covered and the time taken are in direct proportion. So the quantity time taken should be in hours, since the speed of any vehicle by convention, the unit of speed of any vehicle is conventionally is taken to be kilometer per hour. So the quantity y will have the units hour, and the distance covered, the quantity x, which is the distance covered by the truck, is in kilometer. Now remember that now while creating the table, you should be very careful in converting the given values as per the unit. So x is in kilometer and y is in hour. So the first data which we have from the problem is that a loaded truck covers 16 kilometer in 25 minutes. So for the x value, it is 16, which is fine because it is already 16 is already given in kilometer, but the time 25 minutes, it has to be converted into hour. It has to be converted into hour because we have assumed as per the convention that the quantity y is in hours. So I will not, in the while writing the value of y in the table, I will not write 25, but I will write 25 by 60 to convert 25 minutes into hour. So as we know that 25 minutes is equal to 25 by 60 hour, as 1 hour is equal to 60 minutes. Okay, we have this. We have one corresponding values where the value of x is 16 and the value of y is 25 by 60. Now it is asking at the same speed how far it can travel in 5 hours. So let truck travels x1 kilometer in 5 hours. So now we can enter this data in the table. So x1, the value of x, the value of the quantity x is x1, which is as per our assumption that we have assumed that in 5 hours the truck is traveling x1 kilometer. So we have x1 and we have 5. So now we can applying the concept of two quantities in direct variation, we know that the ratio of the corresponding values should be the same. So we have 16 divided by 25 by 60 is equal to x1 by 5. So this implies 16 multiplied by 60, that is after simplifying the left hand side we get 16 multiplied by 60 divided by 25 is equal to x1 by 5. Now we can solve for x1 using cross multiplication, as x1 will be equal to 16 multiplied by 60 multiplied by 5 divided by 25. So this is 5, 5, 5, 12. So this is equal to 16 multiplied by 12. 16 multiplied by 12. So 32 and 16, which is 192. So this is 192 kilometer. So the truck will, we have to find x1. So that is what the question is asking. Because the question is asking how far can it travel in 5 hours, and we have assumed that in 5 hours the truck will travel x1 kilometers. So x1 is 192 kilometers. So the truck will travel 192 kilometers in 5 hours. Okay, let's do problem number 6. If 18 dolls cost rupees 630, how many dolls can be bought for rupees 455? So this is a concept of articles and cost. We know that the cost of an article remains the same unless and until it is stated. We always assume the cost of one article remains the same. So based on the fact that if the cost of one article remains the same, then the number of dolls, the number of articles, and the cost are in direct proportion. So for this we can consider x to be number of dolls and cost. Y is the cost of dolls in rupees. So x is the quantity, x is representing the number of dolls, and quantity y is representing the cost of the dolls in rupees. So now we can create the table x, y. It is given that 18 dolls cost rupees 630. So we have the first corresponding values, x as 18 and y as 630. Now it is asking how many dolls can be bought for rupees 455. So let x1 dolls can be bought for rupees how much? 455. So we are assuming that x1 is the number of dolls that can be purchased for rupees 455. So now we can enter the values, enter the data x1 and 455 in the table. And now applying the concept, we know the ratio of x and x by y should be constant. We can say that 18 by 630 should be equal to x1 by 455. From here we can solve for x1 by using cross multiplication, and we have x1 is equal to 455 multiplied by 18 divided by 630. Okay. So 9 divides 18 with 2, 9 divides 630 with 70, 2 divides 70 with 35, and 35 must divide 455 with 1, and then we have 10, and then we have 105. So this is 3, 13. So 13 dolls can be bought for rupees 455. Okay, let's solve question number 7. If 9 kg of sugar costs rupees 238.50, how much sugar can be bought for rupees 371? So uh, here also we know when the cost of 1 kg of sugar is or will be a constant, will be same. So based on the fact that the cost of 1 kg of sugar is same, we can say that the amount of sugar and the cost are in direct proportion. So first of all, as you can see, the quantities involved, the x and the quantities involved are amount of sugar in kg and the cost in rupees. So we can say x to be amount of sugar in kilogram and y to be the cost of sugar which is in rupees. So definitely when the cost of 1 kg of sugar, that is the rate of the cost of sugar, which is the cost of sugar per kg, it is constant, then we can say that the x and y will be in direct variation. The more amount of sugar you purchase, the cost will be more. So definitely we can say that x varies directly with y. So now let's quickly create the table. We have x and y. It is given that 9 kg of sugar costs rupees 238.50. So 9 for the value of x and 238.50 for the corresponding value of y. Okay. Now it is asking how much sugar can be bought for rupees 371. So let x1 kg of sugar can be bought for rupees 371. So we can now enter the data x1 and 371 in the table. So x1 goes here and 371. So now we can say that 9 by 238.50 is equal to x1 by 371. So from here we can solve for x1 using cross multiplication, and we get x1 is equal to 371 multiplied by 9 divided by 238.50. Now if we convert the decimal denominator as a fraction, we have 23850, and then we have multiplied by 100. Okay. Let's see. We have to do some simplification. So 1 0 cancels out. Now will 2385 is 2385 divisible by 9? The sum of the digits of 2385 is 5, 13 and 18. Yes, it is. So 9 should divide 2385. So 9 to 18, 5, 58, 6, 54 and 5. Okay. Now 5 divides 10 with 2, 5 divides 265 with 53. And of course 53 divides 371 with 7. So this is equal to 14. So 14 kg. So 14 kg of rice of sugar can be bought for rupees 371. Okay. Let's do problem number 8. The cost of 15 meters of a cloth is rupees 981. What length of the cloth of this cloth can be purchased for rupees 1308? Now the concept here is that the cloth should be same and the quality of the cloth should be also the same. Now, if that is same, if the quality and the type of cloth is the same, then uh, the cost of the cloth per unit length is same, should be is same, is a constant. And in that case the length of the length of the same type and quality of cloth will be in direct proportion to the cost of the cloth. So when assuming that the cost of the cloth per unit length, that is cost of the cloth per meter length of the cloth is same, we can say that let x be the quantity. So the two quantities involved are is the length of the cloth and the cost of that particular length of the cloth. So let's say x is length of cloth in meters, and let's say the quantity y represents the cost of the cloth. So definitely, if the cost of the cost of the cloth per unit length is same, then these quantities x and y will vary directly with each other. So the more the length of the cloth is, the cost will be more. Okay. So now if we tabulate some data, create a table x and y. So the quantity x is in meters and the cost of the cloth is in rupees. That is, the quantity unit of quantity y is rupees and the unit of quantity x is meters. Now it is given that the cost of 15 meters of a cloth is rupees 981. So we have the corresponding values for the first data is 15 and 981. Now it is asking what length of this cloth can be purchased for rupees 1308. So let x1 meters of same cloth can be purchased for rupees 1308. So now we can enter this data in the table. We have x1 and 1308. Now from the table and the fact that the x and the quantity x and y are in direct variation, we can say that 15 by 981 is equal to must be equal to x1 by 1308. So from here we can solve for x1. x1 will be equal to 1308 multiplied by 15 divided by 981. Now 981, its sum of the digits is 9 and 18, so it must be divisible by 3. So 3 and 2, 7, 3 divides 15 with 5, okay, and 12. So 3 divides 327 with 1, 0, 9. 3 divides 1308 with 4, 4, 3, 6. Okay. Now 109 divides 436 with 4. So this is equal to 20. So 20 meters is the answer. So 20 meters of the same cloth can be purchased for rupees 1308. Okay, let's solve question number 9. In a model of a ship, the mast is 9 centimeter high, while the mast of the actual ship is 15 meter high. If the length of the ship is 35 meters, how long is the model ship? So basically it is comparing with the model and the model of a ship and the actual ship. Now it is saying that in the model of a ship, the mast, I don't know what a mast is. A mast might be some structure of a ship anyway. So the mast is 9 centimeter high in the model, while the mast of the actual ship is 15-meter high. So you can say that 9 centimeter in a model is equivalent to 15-meter in the actual ship, in the actual structure. That is, 9 centimeter in the model of the ship is equal to 15 centimeter in the actual ship. So if the length of the ship is 35 meters, how long is the model ship? That is that basically, so it is asking that if, so what is the concept? How do we approach? So what are the quantities? First, we have to identify the quantities. Now, you can clearly understand that if the model of the ship and the actual ship must be proportional, that is, uh, a distance, a certain distance in the model of a ship and its equivalent distance in the actual ship, they must be in direct variation. So I can say that, which means that if the more the distance is in the model, definitely the more the distance will be in the actual ship. So if the mast in the model of the ship is of shorter distance, is of shorter height, then obviously that will mean that the height of the mast of the actual ship will also be shorter, since the model and the actual ship, they are in proportion, they are in direct proportion. Or you can say that the dimensions of the model of the ship and the dimensions of the actual ship, they are in direct proportion. So the quantities that we can thought of regarding the two quantities which are in direct proportion is that let x be the distance in the model of ship. Now you must be very careful regarding the units. It is given that the mast is 9 centimeter high, while the mast of the actual ship is 15-meter high. So all the units of the so all the so the unit of a particular distance in the model of the ship is given in centimeter, and the distance in the actual ship is given in meters. So the distance in the model of a ship in centimeter, this is in centimeter. If we are considering the quantity x to be a certain distance in the model of a ship in centimeter, and y to be the distance, that is the equivalent distance in the actual ship which is in meters, Okay, so now we can clearly say that x and y should vary directly, because since the model of the ship and the actual ship, their dimensions are in direct variation, that is, they are in direct proportion. So if the mast, if the mast in the model is, if the height of the mast in the model is small, then appropriately the height of the mast in the actual ship will also be small. And if the height of the mast in the model is more, the more will be the height of the mast in the actual ship. So let's quickly now create a table of x and y. It is given that in the model of a ship, the mast is 9 centimeter high, and while the mast of the actual ship is 15-meter high, which essentially means that a 9 centimeter distance, a distance of 9 centimeter in the model is equivalent to 15-meter in the actual ship. So we have the corresponding values of 9 and 15. 9 and 15. Now it is asking if the length of the ship is 35 meters long, how long is the model ship? So it is asking that a distance of what will be the distance equivalent distance in the model if the distance in the actual ship is 35 meters. So let uh, let x1 let x1 centimeter is the length of model ship when length of actual ship is 35 meters. So we can add the new data as x1, x1 and 35. You must be very careful with the units. So all the corresponding values of y must be of same unit and all the corresponding values of x should be in same unit. So now we can apply the fact that 9 by 15 should be equal to x1 by 35. From here we can solve for x1 as 35 multiplied by 9 divided by 15. So 5 3 5 7 3 3, this is equal to 21. Remember 21 centimeter, not meter, because the quantity x we have assumed to be having the unit in centimeter. So the length of the model ship, the length of the model of the ship will be 21 centimeter when the length of the actual ship is 35 meters. Okay, let's do problem number 10. In 8 days, the earth picks up some kg of dust from the atmosphere. How much dust will it pick up in 15 days? So definitely this is based on the fact that the amount of dust picked up per unit time, per day is fixed. It must be fixed. Then only we can say that the amount of dust and the number of days, the amount of dust picked up by earth and the number of days passed by, they should be in direct variation. Okay, so we can consider the quantities x as, let's say, number of days, and the quantity y to be amount of dust picked up, dust picked up by earth, and this should be in kg, in kilogram. So now if we, based on the fact that the amount of dust picked up by the earth in a day is constant, then we can say that the more the number of days is, the more the amount of dust will be picked up by earth. So we can say that x varies directly with y. Now let's create a table of the quantity x and y. So it is given that in 8 days, the earth picks up 6.4 into 10 to the power 7 kg of dust. So for the value of x we have 8, and for the value of y we have 6.4 into 10 to the power 7. Okay. Now the question is asking how much dust will it pick up in 15 days. So we assume let y1 kilogram of dust amount of it is dust. So this will be not dark, I've written dark, sorry, dust. So let y1 kg of dust is picked up in 15 days. So we can add the new data, that is 15 will be the value of x, 15, and y1 will be the value of y. Okay, so we can now say 8 divided by 6.4 multiplied by 10 to the power 7 is equal to 5 by y1. This implies y1 is equal to 6.4 multiplied by 10 to the power 7 multiplied by 5 divided by 8. So we can simplify this as 64 multiplied by 10 to the power 6 multiplied by 5 divided by 8. So this is 8, this is 40 multiplied by 10 to the power 6 kilogram, and this is equal to 4.0 multiplied by 10 to the power 7 kilogram. So in 15 days, the earth will pick up 4.0 multiplied by 10 to the power 7 kilogram of dust. I think I have done something wrong. Okay, so this is not 5, 15 and 15, and this is 15, and this will be uh, 120, and this is 12.0. 12.0 multiplied by 10 to the power 7 kilogram of dust. Okay, let's do problem number 11. A car is traveling at the average speed of 50 km per hour. How much distance would it travel in 1 hour 12 minutes? So this is a very standard problem regarding distance covered, time and speed. So when the speed is constant, always remember, when the speed is constant, then the distance traveled and the time, they are in direct proportion, or they are in direct variation. So uh, uh, so the quantity involved in this problem is, it is given a car is traveling at an average speed of 50 km per hour. So by that it means that it takes 1 hour to travel 50 km. Now it is asking how much distance would it travel in 1 hour 12 minutes. 1 hour 12 minutes. So the first thing we have to consider is the unit of time. The unit of time should be in hour. So the 1 hour and 12 minutes has to be converted into hour. Okay. So let's identify the quantity x. Let x be the distance traveled by car, and this should be in kilometer. And let's say y be the time taken to travel the x distance. So time taken, this should be, we are considering in hour. Okay, so now we can create the table of the quantities x and y. So the first fact it is given is that the car is traveling at an average speed of 50 km per hour. That is the speed, average speed or uniform speed, they means the same. That is, the speed is constant. So we can say as a first data, it says that in 1 hour it travels 50 km. So we have 50 over here and we have 1 over here. Now it is asking how much distance would it travel in 1 hour 12 minutes. So we are assuming x1 kilometer is traveled by car in 1 hour 12 minutes. Now 1 hour 12 minutes has to be converted into hour, since we have assumed that the unit of the quantity y is in hour. So 1 hour 12 minutes is basically equal to 1 plus 12 by 60, this amount of hour. This is equal to 1 plus 1 by 5 hour, and this is equal to 6 by 5 hour. So now we can add the new data x1 and 6 by 5. So we have x1 and 6 by 5. Now we can apply the concept of two quantities in direct variation. The ratio of the corresponding values should be is a constant. So we have 50 by 1 is equal to x1 by 6 by 5. This implies 50 is equal to 5 x1 by 6. This implies x1 is equal to 6 by 5 multiplied by 50. This is equal to 60 kilometer. So in 1 hour 12 minutes the car will travel 60 kilometer moving at the same speed. Okay, let's solve problem number 12. Ravi walks at the uniform rate of 5 km per hour. What distance would he cover in 2 hours 24 minutes? So the concept is same. This is also the concept of speed, distance and distance covered and time taken. So if the speed is if the speed is kept constant, then the distance covered and the time taken will be in direct variation. So we can say that let x be the distance walked by Ravi, and let's say this is in let the unit be in kilometer, and y be time taken. Now while deciding the unit of the quantities x and y, you should look at the given data. So the first data is that Ravi walks at the uniform rate of 5 km per hour. So the time is given in hour and the distance traveled is given in kilometer. Okay. Now what distance would he cover in 2 hours 24 minutes? Okay. So we need to convert the time 2 hours 24 minutes into hours. So definitely the unit of y, that is time taken, should be in hours. Okay. So now we create the table x and y with the table of corresponding values for the quantities x and y. So first data it is given is that Ravi walks at the uniform rate of 5 km per hour. It means that in 1 hour it walks 5 kilometers. So we have 5 for x and 1 for y. The next it is asking what distance he covered would he cover in 2 hours 24 minutes. So let Ravi covers x1 kilometer in 2 hours 24 minutes. Now 2 hours and 24 minutes has to be converted into hours, since we are assuming the unit of y to be in hour. So this is equal to 2 plus 24 by 60 hours. This is equal to 2 plus 12, 2 by 5 hour. This is equal to 12 by 5 hour. Okay. So we have, we can enter the new data x1 and 12 by 5. So now we can say 5 by 1 is equal to x1 by 12 by 5. This implies, after simplifying, we get 5 is equal to 5x1 by 12. So this implies x1 is equal to 12 into 5 divided by 5, which is equal to 12 kilometer. So in 2 hours 24 minutes, Ravi will walk a distance of 12 kilometer. Okay, let's do problem number 13. If the thickness of a pile of 12 cardboards is 65 millimeter, find the thickness of a pile of 312 such cardboards. Now the concept here is the thickness of each cardboard is the same. Then only you can say that the number of cardboards and the total thickness are in direct variation or direct proportion. So the quantities involved in this problem is the thickness of a pile of cardboards and the number of cardboards. So keeping in mind that the thickness of each cardboard is same, we can say that the thickness of a pile of cardboards and the number of cardboards will be in direct variation. So we can consider X as number of cardboards, in the pile, and Y to be the thickness of the pile. This should be in millimeter. So definitely we can say that keeping in mind that the thickness of each cardboard is same. So thickness of all the cardboards is same. We can say that X varies directly with Y. That is, more the number of cardboards, definitely the thickness of the pile will be more. Now if we create the table X, Y, it is given that the thickness of a pile is of 12 cardboards is 65 millimeter. So we have 12 for X and 65 for Y. Now it is asking find the thickness of the pile of 312 such cardboards. So let Y1 millimeter be the thickness of a pile of 312 cardboards. 312 cardboards. So we can enter the new data as 312 for X and Y1 for Y. Now we can say that 12 by 65 should be equal to 312 by Y1. From here we can solve for Y1. Y1 is equal to 312 multiplied by 65 divided by 12. So I think 12 will divide 312. So 12, 2, 24, 7 and 6. So this is equal to, we have to find what is 65 multiplied by 26. 30, 39, 0, 9, 6, 1. So this is 1690 millimeter. So the thickness of a pile of 312 cardboards is 1690 millimeter. Now we can also convert the unit to you can also convert it to centimeter or even meter. I'm not doing that. Okay. Let's do problem number 14. 11 men can dig 6 3/4 meter long trench in one day. How many men should be employed for digging 27 meter long trench of the same type in one day? I think I don't know what is the meaning of trench exactly. I can guess it is a kind of hole like a tube well. I don't know. So anyway, it is saying that 11 men can dig a trench of certain length, that is 6 and 3 by 4 meter long, in one day. So how many men should be employed for digging 27-meter long trench of the same type in one day? So the day is fixed. So if you fix the number of days, then definitely the more the number of men will be, the more the length of the trench will be, which has been dug by the men. And definitely, if you increase the days, if you increase the number of days, so the quantities involved in these problems are number of days, the length of the trench that has been dug by the men, and the number of men. Now, if you fix the number of days for which the men are working or digging, if you fix that, which in this problem is one day, then definitely the number of men, more men will dig a trench of longer length. So definitely the number of men and the length of the trench will be in direct variation or proportion, keeping in mind that the number of days for which the men are working is fixed, which in this problem is one day. So we can assume X as number of men, and Y as the length of trench in meters. In meters. Then we can say, keeping the number of days for which the men are working fixed, which in this problem is given to be one day, then we can say that the quantity X and Y will vary directly, because the more the number of men, more will be the more amount of trench will be digged, that is the length of the trench digged will be more. Okay, so now let's quickly create a table. So it is given that 11 men can dig 6 and 3/4 meter long trench. So the value of X will be 11, and over here it is 6 and 3 by 4. Okay. Now it is asking how many men should be employed for digging 27-meter long trench. Okay. So let X1 men need to be employed to dig 27-meter long trench. So we can add the new data X1 and 27. So now we see that now it is better you first convert the mixed fraction 6 and 3 by 4 as an improper fraction. So this is 27 by 4. So this is actually 27 by 4. So now we can say that based on the concept that if two quantities X and Y are in direct variation, then the ratio of their corresponding values is constant. We can say that 11 by 27 by 4 should be equal to X1 X1 divided by 27. So after simplifying this, we have 4 multiplied by 11 divided by 27 is equal to X1 by 27. So this implies doing cross multiplication and solving for X1, we get X1 is equal to 4 multiplied by 11 multiplied by 27 divided by 27. So this is 44. So 44 days will be required. 44, sorry, not 44 days, but 44. X is 44. That is 44 men will be required to dig 27-meter long trench in a day. Okay, let's do the last problem, that is problem number 15. Renu types 540 words during half an hour. Okay, how many words would she type in 8 minutes? Now this problem, the data involved is time taken and the number of words typed. Now the number of words typed and the time taken will be in direct variation. They will vary directly with each other only when the typing speed of the Renu is same. It is similar to it is similar to the distance traveled, time taken, and the speed of a car or a vehicle. So when the speed is constant, then the distance traveled and the time taken are in direct variation. Similarly, for this problem, if the typing speed is same, is fixed, is uniform, that is, how many words, the number of words typed per hour is same, then the number of words typed and the time taken should be in direct variation. Okay, so let's say the quantities are x is number of words typed, and let's say y p time taken in hour. Okay, so now let's create the table xy. It is given that Renu types 540 words during half an hour. Now the x value is 540, and remember we have considered the unit of the y as hour. So the y value is given as half an hour, so it is half. Okay. Now it is asking how many words would she type in 8 minutes. So let let's say let x1 words is typed in 8 minutes. In 8 minutes. Now we have to convert the 8 minutes to hour. 8 minutes is equal to 8 by 60 hour, which is equal to 2 by 15 hour. Okay, so we can now add the new data in the table. The number of words we have assumed to be x1. So x1 in 8 minutes, and 8 minutes is equal to 2 by 15 hour. So 2 by 15. So now we can say that 540 divided by half should be equal to x1 divided by 2 by 15. After simplification, both sides we get 2 multiplied by 540 is equal to 15x1 by 2. So this implies x1 is equal to 2 multiplied by 2 multiplied by 540 divided by 15. Okay. So 3 divides 15 with 5 and 3 divides 540 with 180, and 5 divides 180 with 36. So this is equal to 4 into 36, which is 24, 144. So 144 words will be typed by Renu in 8 minutes. Okay, so that was so this brings to an end in solving the 15 problems from exercise 12A, which are all based on direct proportion. Now let's quickly recall what are the concepts and the formulas that we have used in solving this problem. So this is very, very important. I am stressing it very strongly, and I will tell it again and again. I am saying it again and again. Whenever you solve a few problems, a set of problems from the exercise book or from any reference book, or you are giving any mock test in the exam in your at home, after solving the problems, always recall what were the key concepts and formulas that you used to solve the problems. This will indirectly do a revision of all the chapter concepts, and if you do so, your the concepts and the formulas of all the chapters will be in your memory for a longer period of time. So this is super important. Okay, so let's recall the key concepts and formulas used to solve the problems of exercise 12a. The first one is very obvious. So if x and y are two quantities that vary directly, that is, if two quantities x and y are in direct variation, and y1, y2, y3 are corresponding values of y, when the values of x are x1, x2 and x3 respectively, then we have x1 by y1 is equal to x2 by y2 is equal to x3 by y3 is equal to k, where the k is known as the constant of proportion or constant of variation. That is the ratio, essentially the ratio of the ratio of all the corresponding values of the two quantities x and y are same, and it is a constant, and that constant is known as the constant of proportion or variation. The second concept is that given in a model of a structure, so you might have seen the model of a structure. Now the structure could be a building, it could be a ship, or it could be an aeroplane. So there is in the engineering department, there is always a model is first prepared, and based on the model, the actual structure is made or built. So if it is said in a given problem that given in a model of a structure, q distance in actual structure corresponds to p distance in the model, then p by q is the constant of proportion for the following x and y quantities. If you consider x to be the quantity which represents a distance in the model, and if you consider y to be the distance, equivalent distance in the actual structure, then the quantities x and y are in direct proportion, and the constant of proportion will be p by q, where the values of p and q are given, saying that q distance in actual structure corresponds to p distance in the model. Now this is my statement. It could be these values of q and p could be given in a different way, just like in the problem, in the exercise problem number 9, it is given that in a model of a ship, the mast is 9 centimeter high while the mast of the actual ship is 15 meter high. So in this, by p and q I mean the value of 9 centimeter and 15 meter. So it is similar to a map. In a map also there is a scale. A map has a scale, which means that if a map has a scale which says that a particular distance in the map corresponds to a certain distance in the actual world. So let's say in a map it is given that the scale of the map is given that 1 centimeter in the map is equivalent to, let's say, 10 kilometer. I'm just giving an example, 10 kilometer in the real life. So if the distance between two cities in the map is 1 centimeter, then the actual distance of the two cities will be 10 kilometer. So the scale of the map was given as 1 centimeter is to 10 kilometer. That is, 1 centimeter in the map is equivalent to 10 kilometer in the actual world. Similarly, in the model also, the concept is same. So q distance in the actual structure corresponds to p distance in the model. Now this p distance and q distance, p distance might be given in is always given in a smaller unit. Like p distance could be like let's say 5 centimeter or normally in centimeter, and the q distance in the actual world, that is the q distance in actual structure, the q distance usually will be given in kilometers or even in meters. So if you see in a model, if it is given that q distance in actual structure corresponds to p distance in the model, then the p by q is the constant of proportion. Now you can consider p by q, you can also consider q by p, it does not matter. What matters is that the ratio of the distance, the ratio of q and p will be a constant. And if you consider the x to be the quantity x to represent the distance in the model and y to represent the distance in the actual world or in the actual structure, then the ratio, the constant of proportion or the constant of variation, which is equal to x by y, will be equal to p by q. And finally, from all the problems that we have solved, we can list down some examples of direct variation. So the first one is articles and cost. This is a very common thing. You must already be knowing that more is the articles, more is the cost. Keeping in mind that the cost of one article is same, is a constant. It does not change. So if you consider x as the number of articles and y as the cost of articles, definitely x will vary directly with y. The second one is distance covered and petrol consumed, based on the fact, keeping the mileage same. That is, what is mileage? Mileage mileage of a vehicle is how much distance is traveled by the way, how much distance a vehicle can travel in 1 liter of petrol. In 1 liter of petrol, that is the mileage of any vehicle. So if the mileage is constant, then the distance covered in a certain amount of petrol, the distance covered and the petrol consumed, they are in direct variation. So if you consider x as the distance covered and y as the petrol consumed in liters and the distance covered in kilometer, then we will have, then the quantity x and y will be in direct variation. The next one is distance traveled and time, keeping in mind that the speed is uniform or the speed is constant. So for a vehicle, like for a truck, for a car, if a car is traveling at a constant speed or at a uniform speed, then the distance traveled and the time taken to travel that distance will be in direct proportion or in direct variation. That is, more the distance is traveled, more the time it will take. So if you consider x as the distance traveled and y as the time taken, then obviously the x and y will be in direct variation, or x will vary directly with y. The next is men and task. Men, that is the number of men, and amount of task completed. Now in this concept, in this example, the time is constant. That is, in how much time, in how much so time, number of men, and the amount of task. These are the three quantities involved. And if we keep the quantity time constant, that is a certain number of men is completing a certain amount of task in a certain time. So if the time is kept fixed, let's say the time is, let's say 12 hours or 1 day or even 1 week, whatever, if the time is fixed, then the number of men and the amount of task, they will be in direct variation. More you employ, more is the number of men, then the more will be the amount of task completed. Now what is a task? A task could be like reaping a field. A task could be like digging a trench. So now what is meant by the amount of task? What is meant by amount of task? So in the example of digging a trench, the amount could be the length of the trench that has been dug by the men, or it could be the area of the field that has been reaped. So that is meant by the amount of task. So if the time is kept fixed, that is for how much time the men are working for a certain task, if that time is fixed, let's say for 1 day or 12 hours or even 1 week, 1 work or 1 month, whatever, if that is kept fixed, then the number of men and the amount of task will be in direct variation. So if you consider x as the number of men and y as the amount of task completed, then x and y will be in direct variation. The next is the taxi and fare. That is, you are traveling a certain distance by a taxi, the taxi is charging you a fare. So the quantities involved is the distance of the journey and the distance of the journey and how much the taxi is charging, that is the amount of fare. Keeping in mind, here one thing is kept constant, which is the rate of the fare of the taxi, which is how much money the taxi is charging per kilometer. Usually the distance of journey, the distance is conventionally the unit of a distance is taken to be kilometers or in kilometers. So the taxi must be having a rate which is constant. The rate is how much money it is charging for traveling 1 kilometer of the distance. So if that is kept constant, then the amount of for a journey, the for a journey, the distance of the journey and the amount of total charge will be, these two quantities will be in direct variation. So the more the distance of the journey is, more will be the taxi fare or the taxi charge. So if you consider x as the distance of journey and y as the amount of fare, or fare you can consider fare as the taxi charges, these two x and y will be in direct variation. Okay, the final concept is about whenever you are, so you are given a, so whenever you are solving problems of proportion, that is in the, it could be direct proportion or in inverse proportion, the two quantities involved in the proportion, their corresponding values must be in the same unit. So let's say if x varies directly with y, then both the quantities and let's say both quantities x and y have some units, then all the corresponding values of x must be in the same unit and all the corresponding values of y must be in the same unit. So all the corresponding values of x must be of the same unit as x and all the corresponding values of y must be of the same unit as y. So for example, let's say we are having the quantities x and y, the unit of x is kilometer and the unit of y is hour. Now we have one data, we have one corresponding values. Let's say x1 is given in kilometer. We have, when x1 is 16 kilometer, the corresponding value of y, which is y1, is given to be 25 minutes. Now 25 minutes is in minutes, but the quantity y is in hour. So we must convert 25 minutes into hour. So to find the constant of proportion, we know the constant of proportion is x by y. So to find the constant of proportion, k will be equal to x1 by y1. x1 is fine because x1 is already given in 16 kilometer. So x1 is 16 divided by, we will not divide, so it will be 16 divided by, for the value of y1, the value of y1 has to be first converted into hour. So 25 minutes is equal to 25 by 60 hours. So that is why we are dividing 16 by 25 by 60. So these things, these are the, regarding the units, you must be very careful while you are creating the table. While you are entering the corresponding values of x and y in the table, please note, please keep in mind that on the values the corresponding values of x must be of the same unit as x and the corresponding values of y must be of the same unit as y. So these were the key concepts and the formulas and some examples of direct variation that you should consider after solving these problems. So I will keep on doing this section that is very important, which is recalling key concepts and formulas used to solve the problems, and you must also do the same. This will immensely help you in your study and preparation of the chapters before any exam or any test. So I will end the video here. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and once again, please support me by subscribing to my channel and do not forget to press the bell icon so that you will be notified by my future videos. The next upcoming videos will be on the discussion of inverse variation from the textbook of author RS Aggarwal, and then I will solve the subsequent exercise problems. And then parallelly, I will start 10 good problems on this chapter, direct and inverse proportion, in the other playlist, that is Maths 8 Hot. So please keep an eye on these two playlists for my upcoming videos. So thanks for watching, and until the next video, take care and bye.